Hi boys and girls. This video covers the section 5.6, inverses of linear functions. You will notice that we did skip 5.5, that's linear regression. It's not real prevalent on the air test, so under these circumstances we're going to skip that one and move on. This one is important and it's super fun. I think you're going to like it. Let's see. This starts on page 327 in your workbook. Here you have your goals. Construct the inverses of relations. Find inverses of linear functions. Today's vocabulary: inverse relations, inverse functions. Pretty straightforward. Inverse relations are interesting. Let's go ahead and read this with you. Two relations are inverse relations if and only if one relation contains points of the form A, B, while the other relation contains points of the form B, A. Inverse relations are pretty much what you would think. They're complete and total opposites of each other. All right? No, let's see that there. Okay. So here's an example. Let's say that function A has a point -8, 12. Function B, the complete opposite of it, will have a point 12, -8. All right, complete opposites. So what they're saying is that when you have a graph of an inverse, it's the graph of the original relation reflected over the y equals x line. Okay, y equals x, if you've got a graph, an xy coordinate grid like this, the y equals x line goes like this. Okay, so whatever the line was over here, it will be reflected over here. That's basically what this says. It's an interesting concept, and it's not too hard to do. All right, so the first thing they're going to do is they're going to give you ordered pairs from a relation, and they're going to ask you to give the ordered pairs for the other one. Okay. So all you have to do is flip the x and the y, okay? So let's see here. We have -8, 3. They have reversed them. We have 3, -8. Here we have 0, 14. We flip them. We have 14, 0. Here we have 11, 52. Here we have 52, 11. Here we had 12, -6. So we make it -6, 12. Okay. So the inverse relation is these are all the new points. Okay. So determine the inverse of the relation. I'm going to scroll down a little bit, make this a little easier on myself. Okay. So for the first point, we would go 5, -1.4. Second point, we do 6.5. 1.3. For the third one, we're going to have -8 first and 3 second. For the last one, we're going to have 9 first and 3.05 second. And then you can put the braces around it to show that that's a set. Okay. They're going to give you a table and ask you to find the inverse. Well, these are just xy pairs. This is the pair -11, 9, which they've written here. The inverse would be 9, -11. All right, they took all these points out of the table, wrote them as xy pairs, and then we're being tasked to write the inverse. Okay. -8, -3, and 2, 3.5. And then the inverse relation is what they want you to do is they want you to write the new points here that you got, -2, comma, 0.3, -8, comma, -3, and 2, 3.5. And so far so good, right? Okay, so then they're going to give you a graph of a line, okay? The best way to do this is to find some obvious points on the line and write down what they are. So when you're looking at this line, I would say this is an obvious point, this is an obvious point, this is an obvious point, and you can use these points, and what they've done is they've written the points that are obvious to them over here. Then once you have the points, go ahead and write the inverse of the points. Notice that 1, 1 stays 1, 1, and this one becomes 4, 2. Now plot the points of the inverse relation and draw a line. Okay, so -5, -1, 1, 2, 3, 4, 5, -1 right here. -2, 0. 2, 0. Did I do that right? Did I count that right? 1, 2, 3. Yeah, that's right. Okay. 1, 1 should be right here. And 4, 2. 1, 2, 3, 4, up 2. Okay. And so this line, oh, I hate drawing lines on this graphic tablet. It's so hard. It's right there. And what I was telling you before is that inverse is the line reflected over the x equals y line. Well, the x equals y line would be like right here. So you can see what they've done. This part flipped over to here, and this part flipped over to here. A linear relation that is described by a function may have an inverse function that can generate ordered pairs of the inverse relation. Okay, that's math lingo. Basically saying, if we give you the equation or the function, you can change it to the inverse function without messing with the graph. And then you can use the function to go ahead and generate points. So basically what they're saying is if we give you like f of x equals 3x plus 2, okay? You know that f of x can be replaced with y, and that's the first step. Replace f of x with y. Then the second step is to swap out the x and the y. Put the x where the y was, and put the y where the x was. Then solve for y. So you have x minus 2 equals 3y. Divide both sides by 3. And you have the inverse function is x minus 2 over 3. And then you can put it f to the negative 1 of x. That's how we notate that it's an inverse. All right, is x minus 2 over 3. You want to write this in slope-intercept form, you would do f to the negative 1 times x is equal to 1/3 x minus 2/3. Okay. But basically that's the steps. You take the f of x out, you put the y in, then you swap your x and your y, then you solve for y, and then you put f of negative 1 of x in for the y. I'll do several examples of that. Okay, well here they're doing an example of that. Find the inverse of this equation. Okay, so you take the f of x out, and you put y in. Then you swap your x and your y. See how the x is here now and the y is here now. Then we have to solve for y. So let's see, I guess we're going to subtract 10 from both sides, so we'll have x minus 10 over here. Subtract 10 from both sides gets rid of that one. And then the next step would be to divide both sides by 5, which it turns out looking like this. And then you replace this with f to the negative 1 of x. At the very least, the notation is terrifying to a non-math doer. So this looks like calculus, right? The inverse of this equation is this equation, okay? And then they went a step further and they wrote it in the slope-intercept form, like we did on the previous example. Okay. All right, so here's another example. Find the inverse of this linear function. Okay, the first thing they do is they take the f of x out and they put the y in. Then they swap places with the x and the y. Then we solve for y. They added 8 to both sides to get rid of this 8. And then they're going to either multiply both sides by negative 3/2 or divide each side by negative 2/3. Dividing by negative 2/3 is the same as multiplying by negative 3/2. So they're saying multiply. And then you get it all back in slope-intercept form, and you change the y out. You put the f to the negative 1 of x in. Okay. Pretty scary looking notation, but so was the slope formula until you learned what it meant. Oh, did I go the wrong way? Oh no, I've already filled in part of this. These word problems are a pain in the butt. You never know what they want in the blanks. Okay, so first now, okay, they're going to throw a word problem at you. Skylar and Carmen rent a paddle boat at a state park for $15 plus $4 for each hour it is used. The function, now that notice they've got that c of x, okay? That might throw you off, but I included this little study tip down here. With function notation, the f of x, the g of x, or the c of x is just a way to name the function, okay? They all mean the same thing, and they can all be replaced by y. All right. Sometimes we'll have two equations. We make one f of x and one g of x so that it's easy to see that it's two separate equations. Okay. And in this case, they're using c of x. Right. So no biggie. We take the c of x, we replace it with y. Then we swap the x and the y their places. And then we solve for y by first subtracting 15 from both sides and then dividing both sides by 4. Okay. And then we take the y out and we put c to the -1 of x. That's our notation that says we have an inverse function now. So interpret the inverse function, okay? Originally, with the original equation, okay, said you would pay $15 and $4 for each hour it's used. In this equation, you could put in how many hours you were going to do it, and it would tell you how much it was going to cost. Once we get the inverse, we can tell it how much money we have to spend, and it will tell us how many hours we can rent the boat, okay? That's the purpose of using the inverse equation here. So x is the total cost of renting the paddle boat, and c to the -1 of x is the number of hours that you can use the paddle boat. So it's reversed. Only I said it better, I think. Skylar and Carmen have $35. How long can they rent it? Okay. Like I said, in the first version of it, you would tell it how many hours you want to rent the boat, and it will tell you how much you have to pay. The second version, you could say, well, I only have this much money. How many hours can I get? Okay. So they want you to solve for 35. When you put 35 in the parentheses where the x normally would go, that means you take the x out of the equation and you put the 35 in. So the x was here, we took it out and we put the 35 in, and then we solve it. 35 minus 15 is 20. 20 divided by 4 is 5. And that means for 35 hours, they could rent the boat for 5 hours. That was easy. They did most of it for us. All right, so here's our check. Javi. Names. Javi is making candles to sell at an upcoming festival. He's already made 38 candles, and he makes 24 candles each day. The function c of x equals 24x plus 38 represents the total number of candles he has in inventory, where x is the number of days since he began making more candles. Select the inverse, okay? Well, remember with the inverse, what we do is we take this and we change it to y. Then we swap the x and the y. Then we have to get y by itself. We solve for y. So I'm going to subtract 38 from both sides first, which gives me x minus 38 equals 24y. And then I divide both sides by 24. So that means that I now have c to the -1 of x is equal to this gobbledygook. Let me see it. Oh, they've written it in slope-intercept form, so we're going to have to go a step further here. We're going to have 1/24 x, and then we have minus 38 over 24. Which that's going to reduce, at least that divides by 2. So that would be 19 over 12. So 1/24, we'll write over here, 1/24 x minus 19 over 12. Do we see that over there? Oh yeah, here we go. 1/24 x minus 19 over 12. Hey, winner, winner, chicken dinner. Now, using that one, it says estimate the amount of time it would take Javi to make 350 candles. So what you do then is you put 350 in for x, 350 divided by 24 minus 19 over 12, and they said it would take between 10 and 20 days. I don't know, where would they get, wouldn't you think you'd be able to narrow it to one day? Anyway, moving on. Oh, guess what? That is the end. But you know what? The only thing is you're wondering is, what's the secret word, Miss Williamson? Hang on. Have you seen this one? Yeah, it's pretty much viral right now. This is Bernie Sanders at the inauguration. I guess it was pretty cold. But anyway, the secret word for today's video is mittens. All right? And those are some pretty cool mittens. Okay? Well, I hope you enjoyed inverse functions, and I know we're going to have a great time with them in the practice problems. You guys have a great weekend, and I'll see you next week.